This is Dr. Sajja Suneel from Data Science Department. Today I am going to tell you a small introduction to Arduino and Raspberry Pi Kit, which is a continuation for our previous class. In this particular session, you guys are knowing about what Arduino was and what Raspberry Pi was. I already told you what Arduino and what Raspberry Pi was. So we'll know in detail what are the things which are utilized in these two, how these two things are utilized in our IoT system, and how Arduino and Raspberry is going to be utilized. Have a look, guys. As I told you, in this IoT physical device and endpoints, our main topic today was the first one, which is introduction to Arduino and Raspberry Pi. In this, what exactly the things are, what exactly the objectives which we achieved for, and the objectives in this particular topic was introduction to Arduino and Raspberry Pi. The main objectives of this particular topic was we need to gain a foundational understanding for both Arduino and Raspberry platforms, and also we need to learn something about the core concepts and the functionalities of each platform. And also we need to explore the potential applications and use cases for Arduino and Raspberry Pi in various fields. Here we need to develop a basic programming skills for both kinds of platform. Either it is Arduino or either it is Raspberry Pi Kit. What exactly the outcomes which are going to be achieved after successful completion of this particular topic was here. After completion of this particular course, we are able to differentiate what Arduino was and what Raspberry Pi Kits based on their strength and weaknesses. And we are able to identify the suitable application for each platform individually. And we are able to write some programs to control the hardware components using both the Raspberry as well as Arduino, guys. And we are going to troubleshoot both the errors as well as issues which are raised, and we are able to build simple IoT projects by using these two components called Arduino and Raspberry Pi Kit. And have a look, guys. We will go in detail about these particular things. Before going in detail, we need to consider a few things. We need to know more specific about these objectives and outcomes which are depending on the depth and focus of the course. We need to get hands-on experience. Further, the first one, introduction to IoT. As I told you, we need to know about IoT before knowing about this Arduino and this particular Raspberry Pi Kit. We already discussed in our previous classes what IoT was, and we have a quick view about the introduction to IoT. IoT is a network of physical devices, vehicles, home applications, and other items which are embedded with electronics, software sensors, actuators, and connectivity, which enables all these objects to connect together for exchanging information with the help of internet. That is what a small brief definition about your IoT was. And what exactly the components which are existed in this particular IoT? The first one is sensors, which are utilized for collecting the data from environment. Either the data will be based on temperature, the data based on humidity, or based on motion detection, whatever it may be. We are going to collect the data from environment. That's what sensors will do. And coming to actuators, it is going to control the physical devices such as motors, lights, walls. All these things can be controlled with actuators only. And coming to connectivity, with this connectivity, basically connectivity will be used for communication, right? Which enables communication with the help of the things like Wi-Fi, Bluetooth, cellular network, whatever we can use for connecting these sensors, actuators, multiple kinds of objectives, right? And coming to data, information which is collected and processed, then only we will call it as data. Information which is collected and processed. After that only we will call it as data. Got it, guys? And coming to application, smart home, smart cities, industries, automations, healthcare, agriculture, whatnot, in all the sectors our IoT was there, guys. And coming to introduction, we are going to know about how to improve the efficiency and productivity. We need to improve the efficiency and productivity. We need to enhance the decision making concept. You need to enhance the cost reduction. You need to do new business opportunities. That is the major importance of using IoT concept. Here, have a look how a basic IoT device diagram looks like. A IoT device consists of several key components such as RF module, power supply, IoT board. I already told you either it is Arduino or a Raspberry Pi. You can use it. A sensor module, cloud, PC terminal, access point, driver circuit, applications, IoT server, cloud. All these are the different kinds of key components which are existed, which are interlinked in a IoT device diagram. And what are the components? As I told you, there are multiple components: sensors which are used for collecting the data, processors which are used for collecting the data from the sensor to be processed. For that purpose we use processor. And coming to communication models, I already told you, which is utilized for enabling the device to connect with the network such as Wi-Fi, Bluetooth, cellular, whatever you call it as. And coming to power source, we are going to provide energy to the devices such as battery, solar, etc. And coming to the actuator, which controls the physical devices or the systems based on the processed data. And this was a small diagrammatic representation for the smart thermostat, which is shown to you on screen. Once have a look, guys. This was the smart thermostat example for our IoT system. See here, a HEM unit which is placed. To that HEM unit, start thermostat is connected to AC unit. Based on this smart thermostat sensor, the room temperature, if the room temperature will high, it will sense and the information will be transferred to AC device, which is our air conditioner unit, so that it will automatically adjust the room temperature to a constant mode. And coming to the other device, other sensor which is placed, it is going to adjust the water heater. The other sensor which is placed here, which is going to adjust the cloth dryer. The other sensor which is going to adjust the vehicle, electrical vehicle. All these things, all the load controllers, load controller 1, load controller 2, load controller 3, which is used for data communication and controlling signal of that particular device. And this HEM unit, which is going to control the gateway, which is a smart meter, which is external control signal of utility. This is how a smart thermostat will function in a IoT device. In this, the components are temperature sensor, I told you, which is used to measure the temperature, humidity sensor, which is going to measure the humidity levels, processor, which is analyzing the data which is given by the sensors and determines heats or cooling needs, and communication mode connected to Wi-Fi or remote control or any kind of data transfer. And coming to display, which shows you the current temperature, set point and other information. Actuator, which controls the heating or cooling systems. And IoT architecture layers. What are the different kinds of IoT architecture layers which are existed in this? There are 4 different kinds of layer: application layer, data processing layer, network layer, sensing layer. Application layer, data processing layer, network layer and sensor layer. In sensor layer, we are having n different kinds of sensors which are placed. Coming to network layer, there are n number of gateways which are utilized. Either it is a Bluetooth, either it is a Wi-Fi, either it is a cellular network, either it is a cloud. Whatever, all these gateways are going to be utilized in network layer for transferring the information which is grabbed by the sensors. And that information will be sent to data processing layer. Data processing layer is the one which is taking the data and processing it with the help of CPU or placing it in database, and that data will be utilized for applications such as smartwatches or smart homes or smart gadgets or smart vehicles. Now you got it, guys, how the entire information will be done. Sensors first, by using these sensors, the data is going to be sensed, and this data is transferred with the help of network layer. And network layer will process the data to processing unit where the data is going to be processed. Data is going to be processed. From that, a decision will be taken and a decision will be taken. And this based on this decision, the application is going to function automatically. This car is going to be kept on automatic driving mode, or else based on the smartwatch, the decision will be happen, right? And the layers, we are having sensing layer, network layer, data processing layer, application layer. I already told you for what purpose these layers are. It was clearly specified on screen. See here, sensing layer, which collects the data from the environment using sensors in a single line. Network layer, which transmits the data to the cloud or other devices. Data processing, process and analyze the data. Application layer, which provides user interface and interacts with user. And coming to other considerations, security, power management, data privacy, and scalability. These are the other things which we need to consider. Coming to security, IoT devices will place a number of vulnerable attacks. Why? Because n number of introducers are going to try to break your security. For that particular purpose, we need to take some kind of measures like encryption, authentication, and access control. And coming to power management, in this power management, an efficient power usage will place a crucial job for improving our battery power devices. Right, guys? And coming to data privacy, you need to protect your data, which is very essential, guys. And coming to scalability, the IoT system, which should be which should be able to handle a n number of growing devices in the network, so that the scalability will plays a major role. These are the four factors which we need to consider additionally. And also there are some examples which I specified for your better understanding for each one individual. Smart home devices such as lights, thermostats, security cameras. Coming to wearable devices, smartwatches, fitness trackers. Industrial IoT devices, sensors for machinery, supply chain management. Automotive IoT devices, connected cars. These are the best examples for that particular IoT devices. And coming to Arduino overview. Now we will start with discussion with Arduino. Later we will start discussing with Raspberry Pi. And coming to Arduino, which is an open source platform, based on this, it is very easy to use either hardware or software, which is open source platform. And in this Arduino, which is a microcontroller based, which majorly focus on physical computing. And also there are popular boards like Arduino Uno and Arduino Nano, Arduino Mega, Arduino Linux. These are the different kinds of popular boards which are used in IoT industry. And coming to Arduino IDE, which is an interface developer environment. By using this environment, integrated development environment, in this environment only we are capable of doing that particular programming by using Python, integrated development environment IDE. And also basic functionalities such as digital input and output, analog input and output, PWM, serial communication. And coming to applications such as robotics, home automations, wearables, and data loggings. These are the things, a small overview. And what Arduino was. Arduino, in one word, your gateway to electronics and programming. In simple word, I can say you this. But Arduino, which is an open source platform, which is used for building electronic projects, which consists of two major components such as microcontroller boards and shields. Right, guys? Arduino hardware, there are two types, microcontroller boards and shields. Microcontroller boards, these are the physical brains of your project, which contains a processor, memory, and input and output pins. See here, it contains a processor, memory, input and output pins. And coming to popular boards, which includes Arduino Uno, Arduino Nano, Arduino Mega, Arduino Linux. I already told you in a previous slide. These are the popular boards which guys we are using in our IoT projects. Coming to shields, there are add-on boards which provides functionality such as Wi-Fi, Bluetooth, motor control, sensors. All these are the shields of this particular thing. Coming to Arduino IDE, integrated development environment. This was the software which is used to write code, which is used to upload into Arduino board, which is used to monitor the behavior of that particular board. What exactly the programming language was? Arduino uses a simplified version such as C++, which is make very relevant to users, learn for beginners. This is a sample screen IDE which is shown to you for your better understanding, which is Arduino IDE, integrated development environment, which is shown to you. Why Arduino is required? For easy to usage, and it is open source, which is utilized by large community of people, versatility. These are the four features which makes us Arduino to choose Arduino in a simple line. And how it is easy to use. The first factor here, this particular Arduino platform is designed to be accessible to n number of people with no little electronics and programming experience. And coming to why open source, you have your freedom to modify and share your projects. Why large community? There is a vast online community which offering supports, which offers tutorials, which gives you inspiration to know about this Arduino. The last factor, versatility. Arduino versatility, which is used for a wide range of projects from sample blinking LEDs to complex robotics and IoT applications. And getting started, how to utilize this? We need to choose an Arduino board. You need to choose an Arduino board based on this particular board which suits you, your project requirements. After that, you need to install Arduino IDE, download and install the respective software from the official website, which is very common, you guys will do. And coming to the learning, the basic scenario of this Arduino. First, you need to perform. We need to start with simple projects like blinking LEDs, utilizing smoke sensor or else some other kind of sensors or buzzers. The small projects which gives us more controlling of these particular motors and sensors and makes familiar ourselves with this particular platform. That is how you need to learn basics. After that, you need to explore your possibilities. Once you guys are comfortable with those small experiments, now you are comfortably well into complex projects which makes you your experiments with the different kinds of sensors and different kinds of actuators in your concern project. What are the popular Arduino projects? Robotics was the popular Arduino projects which can move, which can sense, which can interact with the environment. That is why this project will become the popular one. And coming to IoT devices, which are created for connecting devices that can collect and transmit the data. Coming to home automation, where we are controlling the lights, we are controlling the appliances, we are controlling the security systems. All this can be done with the help of IoT system, with the help of Arduino only in our home automation. Coming to wearables, in our smartwatches, even in our fitness trackers also, there was a smart Arduino board which is placed, guys. And coming to art and music, where we are creating interactive installations and musical instruments which are utilized. These are the popular Arduino projects. This is about the brief narration to you about Arduino, and much more we will know in the next coming classes. And coming to Raspberry, I will give you an overview about this Raspberry. It is most powerful than the Arduino. That I can say you guys. Why? Because it is a single board computer. It was a single board computer which is more powerful than Arduino. And it runs on operating system which is Linux based, Raspberry or Ubuntu. Right? Those two comes under Linux based only. And coming to versatile applications such as IoT, robotics, media center, education. All these are versatile applications which are more familiarly utilized nowadays in IoT industry. And coming to hardware specifications which are required for this Raspberry Pi: processor, RAM capacity, storage, connectivity options. Why? Because it was a small computer, guys. Single board computer, more powerful than the Arduino. And the programming languages which are acceptable by this Raspberry was Python, C++, Java. You can do by using all these three languages. Anyone you can choose, depends on your project. And what are the example projects? I can say you: home automation, web servers, image processing. All these things are the example projects for Raspberry Pi. What exactly Raspberry Pi was? In one word, I can say you say a tiny computer with big potentiality. There was a probe. He looks small, but he's tough guy, right? Like that, Raspberry Pi was also a tiny computer with big potentiality. To see the Raspberry Pi, it was like your debit card or credit card sized. It was only that much size, guys. It was a credit card size. That's why here I mentioned, see here, The Raspberry Pi is a credit card size computer that packs you surprise amount of power. Got it? Like that it was designed, which is more affordable for accessing and making our popular chargers by hobbyists, educators, and developers. Why? What can you do with this Raspberry Pi means? I can simply tell you, the possibilities are endless. I will let you know how learning to code by using this particular Raspberry Pi. I learn how to code. Python is the most popular language which is used for Raspberry Pi, and there are countless tutorials which are and projects for a starter in online. And coming to home automation, we can control lights, we can control thermostats, we can control other devices. Coming to media center, we can build a powerful media center to stream movies, TVs, and music. These are the beauties, these are the possibilities which makes us endless by using Raspberry Pi. And what you can do with Raspberry Pi, we can do retro gaming, we can do robotics, we can do IoT projects, we can do web servers. Retro gaming, where we play classical video games. Robotics, where we control the robots and other electronic projects. IoT projects, where we connecting internet connected devices. Web servers, where we host our own website and web applications. The key features, it is low cost and looks very small, versatility, GPIO pins, community. These are the key features, guys. Compared to traditional computers, Raspberry Pi is incredibly affordable, and its compact factors incorporate into various projects, and it runs on various operating systems including Linux based. That gives us versatility. These pins allows you to interact with external hardware components, which is GPIO pins. And a large and active community was provided support and support their resources to Raspberry Pi. And what makes this Raspberry Pi models more popular? There are several Raspberry Pi models which are available in the market, and based on their strength and weaknesses, Raspberry Pi 4, which is the latest model which offers impressive performance and features. Raspberry Zero, which is a smaller and affordable option for basic projects. Raspberry Pico, a microcontroller board for smaller scale projects. These are the different kinds of Arduino. Now I will compare both Arduino and Raspberry, and along with the features. See, the first feature was processing power. It will be low in Arduino and it will be high in Raspberry. The second feature, memory. It is limited in Arduino. It will be more in Raspberry. Operating system, no kind of operating system. It is a embedded. You need to configure yourself. But here there is a operating system. And coming to cost, Arduino was low, Raspberry Pi was high. And coming to typical applications, Arduino will allows you sensor based project and simple automation process, whereas Raspberry will allow you complex IoT projects, robotics, and computer vision. So the better option is Raspberry Pi, guys. And when to use Arduino, when to use Raspberry, this also you need to know. Whenever we are performing simple projects, low cost solutions, sensor based application, go for Arduino, guys. That is I specified. And when you are performing complex IoT projects which requires more processing power, more memory, and run on operating system, go for Raspberry Pi. Go for Raspberry Pi. That is why I mentioned this point here. This is a good comparison to know about Arduino and Raspberry Pi, guys. And what are the different kinds of interfaces which are presented with sensors and actuated sensor types? There are n number of types of sensors which are used in IoT projects. I'll let you know small examples: temperature, humidity, light, motion, distance, etc. These are the types. And we are having analog as well as digital sensors. And we will use interfacing with both Arduino and Raspberry Pi. And coming to actuators, the types are LED, motor, servos, relays, etc. are there. And here we are controlling the actuators using digital and analog inputs. And here there are n number of libraries which are available for our easiest controlling process. And coming to communication protocols, I already told you, in the communication protocols, these three will play a major role. The first one is serial communication, which is UART, which is basic data transfer between devices. Coming to SPI, which is high speed communication for multiple devices. I2C, multi-master protocol for connecting multiple devices. High-speed communication between multiple devices and multi-master protocol for connecting multiple devices. Got it, guys? Wi-Fi, Bluetooth, Zigbee, which are used for wireless communication protocols. All these three, Wi-Fi, Bluetooth, Zigbee, which are used for wireless communication protocols. And what are the real-world applications to show our diverse IoT projects? I told you, smart homing, smart lighting, smart security, smart energy management, all these factors comes under smart home. Coming to agriculture, soil moisturizer, which tells us how much water levels are there. Crop monitoring, what was the growth of the plant, is any crop was affected due to what we called any kind of bacteria is affecting the plants. It is going to continuously monitor and update us accordingly. We will respond. And smart irrigation purposes, when the water levels are low, automatically it will send an information to your motor to start itself. Automatically it will pump the water to the crop without the human need. Like this, the advancements are there in agriculture field also, guys. And coming to health center, wearable patient monitoring. Nowadays grandparents are left in homes, as in our day-to-day busiest life, we people are running towards our jobs, and kids are going to schools and their colleges. At that time, the help of these wearable devices, patient is going to be continuously monitored whenever we have such kind of cases also. And coming to industrial automation, sensor based monitoring, predictive maintenance, like voltage sensors which are maintained in industry, current industry, to know about the high voltage and low voltage, to maintain an accurate, we require those sensors. And as how much voltage is utilized from this particular area, how much voltage is utilized from this particular area, how much distribution is required, we can calculate all those things. And coming to environmental monitoring, where air quality, water quality and temperature, everything comes into picture. These are the different kinds of real world applications. What are the basic challenges and what are the basic future needs? Security, protecting devices from data attacks, and privacy, ensuring data is handled responsibility. Power consumption, where we optimize battery life. Interoperability, where we are seeing the seamless communication between devices. Scalability, handling large number of devices. And emerging technologies, AI, machine learning, edge computing, blockchain. All these are the emerging technologies. And along with this, deep learning came into picture nowadays. With these emerging technologies, we can utilize our IoT systems in n number of areas. And that's it, guys. In the coming class, I will let you know in detail about these communication interfaces in a broad review. That's it. Signing off, guys.
Like, share and subscribe. Hit the bell icon for more updates.